welcome to this edition of Silicon Grapevine. And today my guest is Daneil Cooley, a CTO of Silicon Labs. Daneil, hello.
Hi, thanks for having me.
So Daneil, you're Chief Technology Officer at Silicon Labs. Just tell us a little bit about your role, and then we'll dive into some of the interesting things about your life.
Sure. Well, CTO is different in a lot of companies. At Silicon Labs, that means most of the hardware engineering, most of the technology vision, and in our case, the IT and security groups are rolling up into my organization.
Okay. Well, let's go a little bit backwards in time. So you've been, I think, about 19 years at Silicon Labs. You've studied electronics, University of Texas at Austin, Stanford University. So how did you get into electronics? Was it just something that we had in the family, or what?
No, I started as far away from electronics as I think you can get. When I enrolled in university, my goal was to actually be a musician,
right?
Classical musician, and that's what I really wanted to dedicate my life to. I think, through the first couple of years at school, I realized it's not for me. That profession, the lifestyle, the number of jobs that are available. I mean, I love the music. I never lost the passion for music, and I still have it today. But I realized kind of the practical, nature of being a musician, is starving musician or a teacher in most cases in classical. And none of those lifestyles was really what I wanted. And I have a lot of engineers in my family, though, engineers in hard science. So I grew up around that, knowing what that was, not in electronics, more in mechanical and physics. But I fell in love with ICs and semiconductors, and I've really sat here my whole career.
And that falling in love with ICs and semiconductors, really, how do you get into that? Because I mean, from my experience, studying electronics, it's all theories and in the first year or two in physics. So where did that sort of falling in love start?
Yeah, I think about that a lot because I'm trying to recruit and get more people into semiconductors every single day. And when I came into university, it wasn't the hot thing. The hot thing was the internet itself. Right. And all the software and web apps that were being built. So, in many ways, it's kind of strange that I did fall into chip design. But in reality, I got a really good internship at Silicon Labs. Actually, I've been here my whole career. So more than 19 years when you count those internships. And I just saw the amazing talent, the amazing technology, and what these chips were enabling. And I realized very quickly that internet is built on chips. Later, those mobile devices are built on chips. And today, all the AI that we're using is built on chips. And none of that software can run without really amazing chips underneath. And for me, that is just magical.
And when that internship, what do you remember what you had to do in the internship?
100% what I had to do. Silicon Labs had just IPO'd, a very small company back then. This was kind of in the fabless boom of chip companies that were out there. Yeah. And we're a fabless company still today. So for your viewers that want to know where we fit in the ecosystem.
Yeah.
And they didn't really have much experience with intern programs. And I remember that first internship, it wasn't very well prepared. And we have a great program now, but back then it was very nascent. And I had two projects. One was to simulate in Spice, which I had never done. And I had to read the Spice manual, the whole manual, actually. Wow. And secondly, they put me on a customer project, which was foundational, actually, and gave me a lot of appreciation for what our customers have to deal with. And I was creating fixed test impedances for telephony lines. This is modems at the time. Yes. Every country has different RC impedances on their telephony lines. And the first thing a chip comes back if there's an issue, we have to figure out if the impedances are being matched, right? So I created an entire array of very precise impedances to test against those circuits. So I had to learn about how the chips are working, what the customers are thinking, how the data sheets work, and fundamentally how the applications engineering process goes. So I had a great internship, and later on it became more focused on chip design itself, but that first one was very formative.
Yeah, that sounds quite interesting because, in my internship with National, it was pretty much the same thing, going through data sheets and working out what customer problems were. So I think,
and I heard that box of impedances is still being used. I put that together in 2001 or 2002, and it's still being used today. Yeah, modems, there's still a lot going in gas station terminals. A lot of legacy equipment still has those telephony modems.
Well, I did an interview recently, and I was surprised that one of the biggest components that still sells is the MLCC, the multi-level ceramic capacitor. And
Oh
you
yeah,
think about it, you do still need the fundamentals. Still,
never goes away.
it never goes away. What was it like when you started there? I mean, did your family say, okay, great that he didn't do music and he's now into something real?
I was a pretty driven child. I think my mom knew I was going to be, successful, hopefully in whatever I chose. I think she was a little glad I was moving into a profession where I could get a better job from her perspective. But really, they didn't know what chips were.
Mm.
Even though I have a family of engineers, it was mechanical engineers doing power plants or physics, doing physics, theoretical physics. So I had to explain to people like what chips are. And the only thing I could really think was, it's inside your computer. That's what I do. And they said, oh, so you built the chip in my computer. And I was like, well, no, there's chips everywhere, but that's the kind of stuff that I do. These days, I don't have to, really explain to many people what chips are anymore. But back then it was mostly just tell me more about what you're doing. They didn't really understand it.
Yeah, I think that's probably for many engineers actually. So you were, I think you're a senior design manager. You quickly became a senior design manager, and then SVP and GM for IoT in 2012. So how was that progression? I mean, was it just that you were doing so well that you just got promoted or got on different projects?
No, I mean, there's a lot of luck that comes into that stuff.
Yeah.
I mean, I really sat down and dedicated myself to becoming a really good designer. And I was surrounded by amazing chip designers and still am. But especially coming out of university, I was working with people that had invented many of the techniques that are very common in the industry today, especially around RF chip design and close proximity to digital circuits and the techniques we use to mitigate that. And so I was surrounded by just amazing engineers. I wanted to be just like them. And I sat down and did all the hard work, from hand calculations through sims and schematics, layouts, lab validation, and everything else. But I had the opportunity fairly early in my career to move abroad into Asia, to Shenzhen in China at the time. We had acquired a company, and I knew the CEO of that company because he had previously worked at Silicon Labs. And he was looking for someone like me to come over and really drive the methodologies through to the team. So this wasn't like an expat experience where someone's 20 years and they want them to lead the team. This was, they wanted someone earlier career to just have really solid fundamentals and drive the methodologies that we needed to design these mixed signal integrated circuits. So I had the opportunity to do that. And in retrospect, that kind of set me down a different path. I remember at the time being very torn between what to do. And I mean, in professional and personal life, frankly, I was dating somebody and she was pretty amazing, and I wasn't ready to walk away from that. But also I had been offered a pretty substantial block on a new chip to do the full synthesizer for a very complicated automotive product. And it was either that or go to Shenzhen for who knows what, country I'd never been to, a language I didn't really speak. Obviously, I had been around Chinese people, in engineering and in my professional life, but no more experience than that. And I ended up going with the China route. And by the way, I asked my girlfriend to move with me, and she did, and we're now married.
Wow. Yeah.
And this was 2007. It was, Shenzhen was very different than it is today, and it's developed a lot. I knew you were there just recently.
Yes.
Yeah.
Well, actually, I followed you on a talk at the CEO Summit a few times.
Yes. That had to be recorded this time, but that really set me down a different path. And yes, I was an IC, individual contributor designer for a number of years, first in China, but then they asked me to manage the team in China, and that kind of daisy chained into engineering management. But eventually, I could see that I was working a lot with the product managers and the people defining the products, and I could see some obvious gaps there. Yeah. And it's that kind of product definition, soup that happens in any company. Like, where does technical stop and commercial business marketing begin? That's kind of where the divide happens. And the way I was working and kind of some of my aptitudes, I felt like I could do a really, really good job defining the products. That's really what I wanted to do. So I had the opportunity at Silicon Labs to go do that. That meant crossing the divide, though, out of engineering and into what we call marketing.
Okay.
And then you have to develop a whole nother set of skills, know.
I mean, you were in China for how long? For Shenzhen for how long?
I was in Asia for 5 years. I think it was 3.5 years in Shenzhen, 1.5 years in Singapore before I made this decision.
Now, one of the things I think people don't realize outside of our industry is how global and connected we are. And what would you say was the biggest thing you learned from sort of working, cross-culturally, in Asia and the US?
I think by far the biggest thing I learned is that, we can, I shouldn't say we can do our job anywhere. People anywhere can do this stuff. Okay. With the right, methodologies and the right culture, this stuff's doable anywhere. And, in the mid 2000s, there was this, well, you can only do certain things in certain places kind of mentality. And I think now in 2023, we've seen that that's just not the case. But at the time I saw it like right in front of me. And what I really saw was in many cases, very, very, very talented individuals that needed a little bit more, visibility into the learnings that we've had, because semiconductors industry was born in the US. And so we've lived with that. And then as it broke out, I was part of breaking that out. So what I realized more than anything is that really driven people with the correct culture and environment can do pretty much anything. And it's not about where you live. It's not about who you know. It's not about what university you went to. And so that really kind of opened me up to like, okay, this is a global industry. It's terribly hard to do what we do. Our shelf life of our products is relatively short compared to most other things like medicine or media or anything else. And so this industry is going to move around as fast as it can. And that's largely what's played out.
And I mean, being in Asia, it must have been a total culture shock as well, coming from the US.
Yeah, I did it on the cheap. This wasn't an expat experience with, expat communities. My wife and I, my girlfriend at the time, I think where we lived in China, you could draw a 5-mile radius around us and we were probably the only foreigners. And walking down the street, we get all the looks and I have to figure out how to negotiate. I have to figure out how to bank. Banking back then was extremely hard in China. I had to figure out everything. And we're better off, for it. And I had a new appreciation for the culture in China specifically. A lot of the people I was working with had gone through the Cultural Revolution. And I grew up in the suburbs of Dallas, and that's as far away as you can get from that kind of stuff. So, hearing their experiences, it was a formative experience for me. And it didn't stop there. I learned a lot in Singapore. I learned a lot in Norway when I lived there. But that China one was the first one. It was the longest one.
Shenzhen has developed quite a lot since that. As we talked about, I was there for the CEO summit recently, and it's still expanding, and it's still becoming more and more of the hub for the electronics industry, isn't it?
Yeah. Oh, yeah. I mean, Shenzhen has everything. I mean, when I was there, the factories, like the manufacturing of shoes and textiles was still moving out and electronics was coming up. But my goodness, between Shenzhen and Guangzhou, or the Guangdong province in general, South China is just, it's a scale that if you haven't really been there to see with your eyes, it's hard to appreciate when you're there in front of it.
Yeah. Now, you moved then, more recently in 2021 into a CTO role, and that's a bigger role, bigger responsibility. And I guess now you're driving a larger part of the vision and the strategy for the company. Is that right?
Yeah. We've got a lot of great leaders at the company, and we're very fortunate to have a pure play focus. Like most companies don't get that from top to bottom. But yeah, I definitely have my hand in kind of driving the higher level strategy, especially on the technology.
And did you imagine that when you joined in 2000, in whenever it was, almost 20 years ago, that you'd be the CTO?
No. I just wanted to make my boss and my peers proud. I was,
Yeah.
there was, especially early on, doing the hard work to really understand things. And I say that a lot, to really understand things. It's way more than simulating and moving on. It's, the theory, the hand calculations, why this, why that. And starting from scratch like that, it was very challenging for me, but I did get it. And I remember validating my first block on the bench, and it was like, wow, it's magic. The models, everything just worked. It was a bandpass sigma delta, and the first thing you do on a sigma delta is you short the inputs together and you plot the noise transfer function. And it's an imaginary one that I did, so it was like shifted in the frequency domain, and then I saw it, and it was just. I still have that printout of the MATLAB plot of the data because it was so important for me. But no, I did not imagine a career path that I've had, and like I said, there's a lot of adjustments that I've made along the way, from the engineering to the business to the corporate, and then back to engineering again.
Right. And now, let's just talk a little bit about what you do. And basically, the IoT. And since we've been engaging, it's always been around connected devices, smart everything. That's quite a big deal now. I mean, it's pretty much, we've got into everything. And Silicon Labs is doing a lot in that area. So tell us a little bit about what you're doing there.
Sure. So our company's focused on connecting embedded systems to the internet. And we sell chips and software into those embedded systems. This could be a wireless chip, like a Bluetooth radio, or a Wi-Fi chip, or a Zigbee, a 15.4, many different kinds of wireless protocols. But we also do a lot of the processing that goes into those applications. So if you open up a light bulb or a shelf label or a door window sensor, there's only one chip inside running the connectivity stacks and the application. That's what we do. And I've been focused on this since about 2011. And, we started talking about IoT as a company back then, and we really set down this path. And before a lot of other businesses were thinking about it. And I remember sitting in rooms with folks like yourself explaining how the IoT was going to be this amazing thing one day. Trust me, back then smartphone penetration was still very low, and it was a long way to go, and we knew that. But we invested well. We did a lot of M&A to build a lot of core competencies that we didn't have at the time. Like software is the biggest one. We have 2-to-1 in software to hardware engineers at this point in the company, like many chip companies. But so now we kind of cemented this strategy back in 2021. We divested our legacy businesses, or the businesses, the analog kind of core mixed signal businesses, the automotive radios, TV tuners, isolation products, those. So, we did that, said, hey, this IoT thing is going to drive multiple billions of dollars of both revenue and tens of billions of dollars of market cap. And the ones that are going to get it are the ones that focus the most. So we set down that path, sold the profitable businesses, or the most profitable businesses, and are living and dying on IoT now. So it's a great space. It has its ups and downs. The markets are going through some downs at the moment, but they'll be back up. And, bottom line is, app developers in the cloud have more and more reasons to try to connect to anything they can, not just phones and computers, but also the embedded systems that are around us.
And I think you're, like many technologists, quite excited by the stuff you do, and so I guess that sort of goes into your own life as well. So, are you smart in everything in your home, I know you've got we're in Austin. I think you've got a smart home demo lab, but you yourself, I guess you must be connecting lots of things and playing.
Oh
lots
yeah,
of things.
I've got I know some folks at the company with more. I think they're using Raspberry Pis to drive their house. I've got 4 little children. I don't have the time for all of that, but I think I counted it up. I have 237 wireless chips in my house between access points and TVs, the obvious ones you think about, but also connected circuit breakers. My pool pump is connected. Lights, of course, is one of the biggest ones. So, in my house alone, there's 237 wireless chips of some sort. and it's probably going to go up every year here. And I know not all homes are that way, but I bet you have dozens of them. I bet most people do and not realize it.
Yeah. Well, it's funny because because you know what goes inside it, but most people won't know how many chips, wireless chips, are in their systems because they just see, like in front of me now, a microphone or a laptop.
Well, that's right. Like they may have a Nest thermostat on the wall, and they know they. If you ask them, is there a wireless chip? They'll say yes, but when they look at it, they don't think about it being a wireless product. Unlike a cell phone, you look at your mobile phone and it's wireless, but you look at a thermostat and it's thermostat. And the beauty of what we have to do is we have to bring this technology into those applications that consumers and businesses, frankly, don't think about as wireless products. But our customers rely on us to bring that technology in a way that doesn't break the cost or power or performance budgets.
Well, one of your recent presentations I saw was, I think, was it a connected dog, or at least there was a dog on was it a dog or a cat? I can't remember.
I think it was a cat. Yeah.
A cat,
I use that as an example. Back in 2011 was when the iPhone 4S was the first mobile phone with Bluetooth Low Energy supported natively in the OS, and people were predicting internet connected pets, and today we have those now. And so back then it was just a crazy thought. So yeah, I like that example.
Yeah, I think I saw it in one of your recent presentations, and I thought it was a dog or a cat. I can't remember, but we see dogs and cats all the time. What's the most strangest sort of connectivity that you've seen, or the place, like a smart something, or is there something that you sort of impressed you? I mean, either strange or impressive.
I got a couple of examples, and I think in hindsight, they're obvious, Nitin, but up front, you're just like, what the heck is going on? Why would you ever need to do that? Yeah. A kind of funny one is a customer put a big order in a few years ago for hundreds of thousands, maybe a few millions of Bluetooth chips. And we're like, what is this? It came out of nowhere. And they were going into fidget spinners. And I thought, my goodness, does the world need a Bluetooth connected fidget spinner or not? But it was shocked me because the bar has come so low. The bar has come down so much to introducing this technology that someone was like, yeah, let's do this. We'll write a mobile app and we'll put it in a fidget spinner, and it went. So that was just an example of how easy it is to use this stuff. But if I have to really think about an application that surprised me, it was probably in a pub, a beer tap, open, close. And one of our customers was putting wireless chips in those because they had small screens on them and they wanted to display either advertisements or the logo of the beer that was there. And I thought that's great. So they were driving revenue, through this, and
that's
then they were
clever.
but then the customer told us they this is what happens in the IoT. People put this stuff in there and then something else happens. And what happened in this case was they put a read switch to detect the state, open or close of the tap. And they were aggregating this data back in their cloud. And what they found was that many beer taps were open all the time. And, and they couldn't figure out why. They thought that there must be, a defect or its sensor is faulty or something, but no. And so what they found was that, throughout the night when you ran out of beer, they would put it down, leave it in the open position. Right. So that the bartender can look down the bar and just see quickly what's available. Well, they turned this into a sales motion, and they went back to those companies and they went to Budweiser, they went to the beer and said, these bars are running out of beer. The last thing you want on a busy night is to be out of beer. So those beer companies could then go to the bars and say, hey, take 2 or 3 extra kegs so that you don't run out. We know you're running out because you ran out like over the last month these many times. And so, it was just like, wow, the simplest things can have downstream effects that you don't really predict. So that was an interesting one for me.
Well, I think that's basically speaks to the fact that when you have data and you do something with it, it allows you to do something more useful. But
even the simplest data doesn't have to be gigabytes, just on off can be transformative for embedded systems.
Let's go back to your interest in music. Did you play anything? Did you play?
Yeah, I played and I still play a little bit the clarinet. So I was pretty competitive there, and and I really wanted that to be my thing, really in professional symphonies. But there's just not many jobs in it, and it's incredibly competitive, and you have to dedicate most of your waking hours in life to being, a really, really good musician.
And do you still play, or?
Some, not as much as I used to.
Yeah.
I'm in a phase in life where it's really family and work is the main tension. Hobbies, I don't know what hobbies are at the moment, and that's okay. My kids are small, and they won't be small forever.
And will you encourage your kids to play
music? Well, yeah, we're doing that with piano. We'll see how long it lasts. My oldest is almost 12, and I think at some point he's going to stop. But we'll have to see.
Yeah. So let's. You have actually sort of maintained that interest. Your outside interest. You're involved in a symphony orchestra as well, I think, and or at least on the board or chairing something. So tell us a little bit about some of the things that you get involved in.
Yeah. So I mean, I do try to participate in the community. I lived enough places for long enough to see the benefits of real community involvement. And so when I moved back to Austin, I didn't want to just, be employed and go to work every day. So I volunteered with the Austin Children's Museum. I do a lot of volunteering at the University of Texas here in town, the University of Texas at Austin, with multiple departments. And recently I joined the board of the Austin Symphony Orchestra. So I always try to dedicate, what amounts to dozens of hours a year. This isn't hundreds of hours a year, but it's, it's enough to have some impact and definitely see what's going on in the community. And then it allows me to see the banking side of the things, the policy side, the lawyers, the doctors, and get out of my tech bubble, because it's so easy in our industry to live in this tiny little tech bubble. And then, I would go from my meetings at Silicon Labs where we're talking about everything is global, it's tech, and it's this. And I would go to the Austin Children's Museum, and they're like, how do we, lower the bar so that a school can visit here without breaking their budget? And it turns into a very different kind of world. And I don't want to ignore that side of the world.
Yeah, I mean, that's actually quite important. I mean, after the ARC IPO in 2000, I left in 2002, I started doing a lot of local voluntary stuff in education and boards of universities and charities. But yeah, it is fulfilling. So I think I see where you're going. And it's not hours and hours, but you give some time.
You can have a big impact for a fairly small number of hours. It's not zero, and it's not one or two, but it's not hundreds.
Yeah.
I just think we're in tech. We live in a very, very. It's hard what we do, to be clear, and it takes a lot of effort and grit and blood, sweat, and tears to do it. But we don't deal with some of the bigger problems that are out there. We are fairly well paid in our industry. We get to work on new technology that's many times not constrained by legislation and regulation because it's so new. Most industries are not like ours. And every time I get out of it and talk to those people, like it hits me like, oh yeah, the rest of the world's very different than tech.
Definitely. What excites you most about the industry today, and what is it that drives you every day?
A few things. I mean, one, I get to see my technology everywhere. We ship about 1 billion wireless chips a year, and I can see them in products that I can purchase and use, and the value that they're creating out there. Two, chips are more important than ever, and I think the world has woken up to that. And there's, through the pandemic and the lack of chips, frankly, but there's some pros and cons that come with being more in the microscope or the, the visibility of the, the rest of the world in the moment.
I hear that a lot. Yes.
But, there's I think every nation and key company on the planet now knows that they need a silicon strategy. And if they don't have that, they're in big trouble. And so we saw, the world have a wave of energy, waking up to the realities of energy. And I think the world is going through that right now in semiconductors, because, these things are coupled and you can't really do what you want to do for your economy, for your military, for anything without chips. So it's nice to know that. There was times in my career where I wondered, maybe I should have gone into software. Maybe I should have done that internet thing. And I had opportunities to be a part of some of these companies like Facebook very, very early. but now I'm really happy, and I made the right choice. I know that. And it's also very rewarding on the technology side, because in my opinion, the coolest tech is done on the chip, whether it's software running on the chip or the building of the chip itself. Every single discipline is there. And so I get to work with people doing everything from semiconductor physics to transistor design to cloud software to embedded firmware. And it's very rewarding from that perspective.
And that's on a sort of work front. But what excites you? And additionally, what excites you personally? Yeah, what what do you like doing? What's your hobbies nowadays when you do get time?
Kids. I mean, I get to see my kids grow. I'm a pretty hands-on dad when I'm not in the office.
Yeah.
And so seeing my children grow up, and they age from 1 to about 12. So there's a pretty good spread there of 4 kids, and just seeing that, and it is probably the biggest thing that I do. And frankly, it takes the most time. That outside of that, I might catch a football game a few times a year, or visit the symphony, which is across the lake here. But really, Nitin, it's work and family at the moment.
Great. And that leads very well into my sort of final sort of thought from you. What would you tell a young Daneil, knowing what you do now, what kind of advice would you give to a young Daneil, somebody who aspires to do what you've achieved?
That's a great question. And I knew that you were going to ask that. But, in this moment, I'd probably say 3 things.
Yeah.
I never set out with a specific career goal in mind. Okay. Like 10, 20 years from now, here's what's going to be the case. Or I kind of had a 5-year, okay, I can kind of see 5 years, 10 years is too long. 2 years is not long enough. I'd probably tell myself, that's fine. Don't worry about that. There was times when I was like, should I be setting longer term goals? Like if you're a doctor or a lawyer, that's pretty, there's career tracks there that are more well defined. In engineering, it's just anything can happen. So number 1, just you're good, stay there. Number 2, shut your mouth more, listen more. There's times, especially I see earlier career folks, that listening can be the best skill a lot of the time. And I wish I had listened, not to what people were telling me, but just listened as a form of communication a lot more. And then probably 3rd, you're going to fail. Failure, if you're not failing, you're not taking risks. If you're not taking risks, you're not adding value to the world. And it's coupled. These things are highly coupled. And, just be ready for it and get back up and keep going, and, try not to take it so hard. You take it very, very hard. And that also, the further you advance in your career, the bigger the implications of both success and failure become. And so you need to be ready to own that and be accountable for that. So it feels great to be a success, and it can feel terrible to fail, but you can't get lost in it. And so, just do more work getting ready to fail. Not that failure is the goal. You know what I mean, right?
Yeah.
But failure comes, and in our industry, it's very hard to predict the future. It's very competitive, and 100% success rate probably means you're not doing enough.
Yep. I mean, without failure, you don't learn, and without learning, you don't grow. So I think it's important. So, Daneil, thank you very much.
All right. Thank you very much, Nitin.